All right, so hi everyone, welcome back today. So I will be going over stoichiometry worksheet. So during one of my tutoring session, this problem set came up, and I thought this would be a good one to work it out. So this will be general chemistry. I know I typically do OChem, but I also do general chemistry, so I figured I will work this problem set out and explain it. This problem has a lot of balancing equation and then also doing stoichiometry, which I think a lot of people find that to be a lot harder. So let's get into that. So the first thing that you want to do with this problem set is that first balance out the equation. That's number one. Two, read basically what this is saying over here, and then get the molecular mass of some of the key intermediates. All right, so let's get into it. So how I would like to start these type of problems is by just strictly just listing out all the different components that I have, and then just like trying to balance it out. So I'll start. So we have calcium. We also have oxygen. We have hydrogen. We also have sulfur. And then on the other side, the same way, we have calcium, we have oxygen, we have hydrogen, we have sulfur. So looking on the left-hand side, seems like we have one calcium. And the right-hand side, same thing, one calcium. We have a total of, let's see, 2 plus 4. That should be 6. And then let's see how many hydrogens we have. We have 2 plus another 2, so that should be 4. And let's see how much sulfur. We just have 1, so that one's pretty easy. And then let's see what we have on the right-hand side. We have 1 calcium. We have how many oxygens? So 4 plus 1, that should be about 5. And then how many hydrogens? We have just 2 right here. And then how many sulfur? Should be just 1. So it seems that the calcium is pretty balanced. So if I put 1 here and I put 1 here, that means I have 1 calcium. That checks out. Now let's try to balance the sulfur. We also have 1 on both sides, so that looks good. So now we have to balance out the oxygen and the hydrogen. Seems like we have 2 hydrogen on the left side over here, and we have 4, excuse me, and then we have 2 right here. So I'm just gonna turn this and make it a 4 by just putting 2 here. So if I put 2 here, so that means the number of hydrogen is going to be 4, which looks good. And now let's double check oxygen. So on this side right here, we have, how much oxygen do we have? We have 2 plus another 4, so that should be 6. On this side, we have 2 plus 4, that should be 6. So that checks out quite nice, and I think that's it. All right, so now that we have a good balanced equation, we can start reading the problem. So it says, how many grams of calcium sulfate would be formed if 130 grams of calcium hydroxide reacted with the excess sulfuric acid? So starting out with the equation, we know that we have 130 grams, and we're just going to put calcium hydroxide here. So that's in grams. Everything else over here are all in moles. So in order for us to go from grams to moles, we just have to we need the molecular mass of this. And this is actually this. So grams will come at the bottom. So we'll put grams of calcium hydroxide. What comes out will be 1 mole. And we get that from the molecular mass of this, which will be 74 grams of, this would be calcium hydroxide. So now what we want to do is go from calcium hydroxide to calcium sulfate. And what we need is the mole to mole ratio, and we get that from this equation. So that's why we needed to balance this equation. So we'll write calcium hydroxide over here, and then this will be moles, and then we need to write moles of, in this case, calcium's sulfate. So there's calcium. So looking at the equation, there's a 1-to-1 ratio. So I'll go ahead and put 1-to-1 right here. And the last bit, so now we have transferred everything into moles of calcium sulfate. But now we want grams of calcium sulfate. So all we need to go from the moles to grams, and we could use the molecular mass to do that. So over here, we'll put moles of calcium sulfate. And then over here, this would now be grams of calcium sulfate. Perfect. So we know that we can use the molecular mass, which is 1 mole is equals to 136 grams. So let's make sure all the units make sense. This will cancel out. This will cancel out. Cancel out, cancel out, cancel out, cancel out. So at the end, we are going to have grams of calcium sulfate, which is what we want. So let's go ahead and get our numbers ready to go. So what we have on top will be 130 times 1 times 1 times 136. And then at the bottom, this would be 74 times 1 times 1. So if you go ahead and do the calculation, you will end up get 240 grams of calcium sulfate. All right, so let's do the last problem. And then again, we will need to balance this equation out. And you start by just writing out all the different components there is. Okay. All right, so let's go ahead. So right now we have 3 PBU on that side. We all have just 1 on this side. We have, let's see how many phosphorus. We have 4 on this side. How much do we have on the other side? We have just 2. Let's see how much oxygen that we have. So we have 4 times 4 plus 3 times 2. So sometimes you need to 4 times 4 plus 3 times 2. Sometimes you just need to write these things out for yourself. So let's do 4 times 4, 16, and then plus 6. And then for BA, we should have just 1 on this side. But on the other side, we have 3. Let's go ahead and do the oxygen on this side right here. So we have 3 times 4 plus 4 times 2. And then last bit, we also need to calculate how much nitrogen. So that will be 2 right here. And then this one will be just 4. So that's pretty much how you go about it. So then let's quickly balance this out. This one is actually pretty easy. And you can actually look at the numbers, but I'll quickly fill in the numbers for us. So this one should be 1 right here. This should be 6. This should be 3. And then this should be 2. So that is our balance equation. Then we're going to move forward into the question, which says how many grams of barium nitrate will be needed to make 325 grams of barium phosphate, assuming that you have excess lead phosphate. So basically we are starting with 325 grams of barium phosphate, but now we want to know how much of the barium nitrate we will make. So we'll start with what we know, which would be 325 grams. So grams of barium phosphate. And at the bottom, we'll write the same thing. We'll put grams of barium. On the top, we'll need to go to moles because everything else is in moles. So all of these right here are all in moles. So we need to convert everything into moles. And how we do that is just use the molecular formula. So looking at it, it seems like the molecular formula for barium phosphate is 601 per 1 mole. Okay, with that, we want to bring at the bottom. Now we can do the mole to mole transfer. So we'll put mole of barium phosphate. Then at the top, we want to put barium nitrate because that's how much we want. And looking at the equation, for mole of barium nitrate, that should be 6. And then for mole of barium phosphate, that should be 2. Cool. So now that we have able to convert that, we can go ahead and write down at the bottom mole of barium nitrate. And now we can do grams over here. And then as always, we can use the molecular formula to convert. So that should be 1 mole to about 261. So if we go ahead and cancel the units out, we should end up with grams of barium nitrate. And then this comes out to be 423 grams of barium nitrate. So that's pretty much it for you guys. Please don't forget to like, share, and subscribe to this channel. And I'll see you guys in my next video. Bye, y'all.